Okay, in this problem, we are going to use the first or second derivative test. Actually, since I've done the problem, I'm going to tell you right now. It's fun to play with, but I'm going to tell you there's certain problems that you just don't need to do a second derivative because it gets hideous. And then as soon as you see something get pretty ugly, there's a message there that maybe you went too far, right? And that's a good ending. Just telling you from experience, lessons learned. By all means, test it out. But sometimes you just don't need to go that extra step. And you can pretty much get most of this just from the first derivative. So if we just look at this, you can actually see the y-intercept from this one, right? Where we would say that in that case, x is equal to 0. Well, if that's the case, f of 0, that's going to be 0. Oh, we already have that. I don't even care what's left because that's just minus 16. That's 0 anyway. So you already see that it's going to be one of the intercepts of the x-axis is 0, 0. And then the x-intercept, this is when y is equal to 0. Well, watch what happens. This would then imply if y is equal to 0, oh, you have 0 equals x squared all over x squared minus 16. That implies, well, that's x equal to 0. Because just solve for x. X is 0. So again, you're going to get 0 over 0, 0, 0. So you know something's happening here already. So what can we do? All right. Let's do our first derivative test, which is going to be quotient rule. So that's just going to be x squared implies u prime 2x. V is equal to x squared minus 16 implies v prime is equal to 2x. So now we can put it all together. So f prime is going to be equal to the following. Low, right? So my low, which is v d high minus high d low all over low low right there. So I'm doing my yodeling. So I'm going to put all the pieces together now. So this is going to be my v. So I'm going to have x minus 16. And this is x squared, obviously. This is going to be times 2x minus, this is going to be u, which is my x squared, times v prime, which is then 2x, all over x squared minus 16 squared. So reduce the top. So then we're going to just have 2x cubed minus, this will give you 32x minus, this will be 2x cubed all over x squared minus 16 squared. This is then going to be 32x all over x squared minus 16 squared. There we go. So this is our first derivative. So we're pretty much, and you know what? This will do it for us. We won't need to do anything else other than that one. So notice too that right away, if we were to look at this, this will also tell us additional information. So these are going to tell us constraints, right? X here, squared minus 16, shouldn't equal 0. We can't equal 0. So that means x can't be plus or minus 4. So that tells us additional information. So that's telling us our vertical axis, or vertical asymptotes, right? So these are vertical asymptotes, right? Those are vertical asymptotes. So right away, I can do my sign diagram. So if I do this, we know there's 0, we know there's a minus 4, and then we know there's 4. Great. That's all we're going to need. Because guess what? If I do, for this, if I chose f prime of minus 5, if I put it in here, the denominator is always going to be just positive. Just positive, because you don't care, because x is going to be positive. This will be, the whole thing is positive. The only thing that matters is here, the numerator. That's negative. So this is going to be, any negative here is going to be positive. So this is going to be positive, positive, negative, and negative. Those are the only places, because if I put in positive, the negative is going to remain. So that means what we have here is increasing, increasing, and then the other one here is decreasing, decreasing. So guess what? What do we have here? Look at this. It's going up and down. So if it's positive on this side, negative on this side, we got ourselves right here at 0, a maximum. Okay, great. Fantastic. What's that point? Well, if we put, hey, guess what? It's 0, 0. Oh, there, that's what's happening right here. This is a maximum, right? So that's what it's telling us. The other thing, if we know our vertical asymptotes, could we find the horizontal asymptotes? Look at the function. Let's just take a look at this for a second. So I'm going to test, and yeah, so test horizontal asymptotes. Horizontal asymptotes. Spelled funny, asymptotes. So what do we have? It's going to be f of x is equal to x squared all over x squared minus 16. Okay. One of the things you want to do with this is take the limit as x goes to infinity. Well, pull out the x squareds from the denominator and numerator, and you can cancel them. So I'll just show you. So you're just going to have 1 here, all over 1 squared, 1 minus 16 over x squared, right? Those cancel. That is equal to then the limit as x goes to infinity, or positive or negative infinity. So you can actually go positive or negative infinity with this one, because it still will work. And you can test that. Just go in and test it and see what happens. This, if I take the limit, this is going to be 1 over 1 minus 0, which is just 1. Ha! My horizontal asymptote is 1, right? Remember, the degree is the same in numerator and denominator. When that's the case, you know that your horizontal asymptotes are whatever the coefficients are in front of your x. That's how you know what it's going to be. So just remember, this acts similar to a linear over a linear, right, for horizontal asymptotes. So already we can see, we can draw already a point here. So that's our 0 over 0. And we know 1, 2, 3, and 4. So that's my minus 4 here. 1, 2, 3, 4 here. So we're just doing a sketch. Right? So we can kind of already have an idea here. Right? Right, so we have that. So we know nothing can pass that line. So this is our vertical asymptotes. This is vertical asymptote. Okay, so we also know the horizontal asymptote can't be, that's my 1, right? So we already know. So what's happening? Well, let's just draw the function. We know it's increasing. Well, if it's increasing, it's coming in from negative infinity. The only thing it can do is this. Go up. So that's increasing. Because it's going the other way, it'd be going negative. Can't do that. You can't do this. So it can only be doing that. So, and then the other thing is, you know, it's increasing here. Well, the only way you can have that, and it peaks there and comes back down. So it's a parabola. right? And then again, it's decreasing on the other side. And there you go. We just sketched it, right? It's actually not that bad. So that's how you manage to do that. And then all you would need to do, well, no, actually that's it. You already know the points. There's nothing else to do. You've sketched it. You know that's your 0, 0. Yeah, you're done. So that's how you do that.